Hey guys, I am your junior maths coach and I welcome you to Junior Maths Mastery class, where I'll be taking you through the journey of mathematical concepts in junior mathematics. Fasten your seatbelt as I take you through the journey of these mathematical concepts with easy steps and method. So for today's class, we are going to focus on the topic factors and highest common factors. When I say factors, factors can simply be defined as numbers. Numbers that will divide a particular number without remainder. Here is what I'm explaining. For instance, you have the number 4. You will agree with me that 4 can be expressed as 1 multiplied by 4, right? And I can also say 2 multiplied by 2, right? Very good. And I can also say 4 multiplied by 1, which is the same thing as saying 1 multiplied by 4. Do you agree? Very good. As such, you will agree with me that our 4 here can be divided by 1 to give us 4. It can also be divided by 2 to give us 2, right? Very good. And it can also be divided by 3 by 4 rather to give us 1, right? Very good. So therefore, 1, 2, and 4 are factors of 4. Do you get that? And that is because 1, 2, and 4 are numbers that we divide 4 without remainder. Do you understand? Very good. So now we are to express 5, 7, 8, 9, and 10 as product of two numbers. Here is what we are talking about. When you say 5, two numbers that we multiply together to give us 5. We have 1 multiplied by 5, right? Good. And I can also say 5 multiplied by 1 is the same thing. Do you agree? Very good. That is for 5. How about 7? 1 multiplied by 7. Good. And I can also say 7 multiplied by 1. Right? Any other number? No. So to the next number, which is what? 8. Let's express 8. We can say 1 multiplied by 8, right? Good. Another one. 2 multiplied by 4. Good. We can also say 4 multiplied by 2, which is the same thing, right? Good. And I can also say 8 multiplied by 1, which is the same thing as saying 1 multiplied by 8. So we don't need to repeat them, right? Good. And as for number 9, it can be expressed as 1 multiplied by 9. What else? 3 multiplied by 3. Very good. Is there another? 9 multiplied by 1, which is the same thing as saying that 1 multiplied by 9. Very good. And to the last number, which is what? 10. Let's express 10. What do we have? We have 1 multiplied by 10. Very good. We also have what? 2 multiplied by 5. Great. And I can also say 5 multiplied by 2, which is the same thing as saying 2 multiplied by 5. And also 10 multiplied by 1. Do you agree? Very good. So we can deduce that each digit of the product of a number is a factor of that number. Here is what I'm talking about. When you look at number 9, each digit of the product of 9, that is 1 multiplied by 9, that's 1, 3. We don't need to repeat numbers. 9. These three numbers, 1, 3, and 9, they are factors of what? 9. Do you get that? So easy, right? Good. How about the number 10? I have 1, 2, 5, 10 as factors of what? 10. Can you see that? Now let's go back to the previous numbers. Our conclusion still remain the same here, that for number 5, factors of 5 will be what? 1, 5. Right? Very good. How about 7? 1, 7. Do you get that? Very good. How about 8? 1, right? 2, good. 4 and 8. Do you understand? Very, very good. And so easy, right? Yes. So now we have an instruction to find the factors of these numbers 11, 12, 13, 14, and 15. To start with, factors of 11. So let's try to express 11 before we list out the factors. We have what? Let's express 11. We have what? 1 times 11. Very good. Any other number? Good. 11 multiplied by 1, right? Which is the same thing as saying 1 multiplied by 11, right? Very good. And as such, factors of 11 are what? 1 and 11. Do you see that? So easy, right? Very good. Now the next number is to find the factors of 12. Factors of 12. Remember, let's express 12 as a product of two numbers and then we list out the numbers starting from 1. So we have what? 1 multiplied by 12. Right? Which other number do we have? 2 multiplied by 6, right? Another one, we have 3 multiplied by 4. Very good. Another one, we have 6 multiplied by 2, which is the same thing as what? 2 multiplied by 6, right? Very good. So these are the numbers that we can multiply together to give us 12. So what we do next is to list out the factors of 12. So factors of 12 will be what? Starting from the beginning downward and to the next number to the last. So we'll be having what? 1, very good. 2, 3, 4, 6, and 12. So easy, right? Good. And now the next number is 13. We find the factors of 13. We need to express first so it can be easier for us. So we have what? 1 multiplied by 13 and 13 multiplied by 1, which is the same thing, right? Do we have other number we can multiply together to give us 13? No. Very good. So let's list out our numbers. We have factors of 13 are 1, 13, right? So easy, right? Very good. And the next number to find its factor is 14. Factors of 14, let's list them out. We have 1 multiplied by 14, right? Give me another. 2 multiplied by 7, very good. Another one, 7 multiplied by 2, which is the same thing as saying 2 multiplied by 7, right? Good. Is there another number we can multiply together? No. So now we list out our factors from the product. So factors of 14 will be what? 1, 2, 7, and 14. Do you see that? It is so easy, right? Very good. And to the last number, which is 15. So we have to find the factors of 15. So start by expressing 15. We'll be having 1 multiplied by 15, right? Very good. We also have what? 3 multiplied by 5, right? Any other one? 5 multiplied by 3, 15 multiplied by 1, which we already have, right? Very good. So we list them out. From the beginning, we have what? Factors of 15 are what? 1, 3, 5, and 15. Do you see that they are so easy to get? Factors of numbers are so what? Easy to get. So easy, right? Very good. And so the next thing we look at is common factors of numbers. We already know that factors are numbers that will divide a particular number. Like when we mention 12, factors of 12 are 1, 2, 3, 4, 6, and 12, right? Good. So common factors are factors that you will see in a particular number and another number. Sometimes it might be more than 2. Do you understand? So now we have to find the common factors between 12 and 14. So now let's take it to another level. We are going to list out the factors of 12 and 14 without the expression method, without expressing numbers, without expressing product of numbers. Do you get that? So now you can do it, right? Very good. So starting from 12, factors of 12. We have 1, very good. 2, you can see it is easy. 3, good. We have 4, 6, and 12. So easy, right? Very, very good. So now for factors of 14, list them out without expressing. What do we have? Starting from 1. We have 1, 2, 7, and 14. You can see it is very easy to figure out. Very good. So now what we do, our common factors will be factors that we can see in 12 and at the same time we can see them in 14. Let's figure them out. There is 1 here, there is 1 here, right? So we have 1. There is 2 here, there is 2 here, right? So we have 2. Any other number? We have 3 in 12, there is no 3 here. We have 4, no 4. We have 6, no 6. We have 12 and no 12 here. Likewise for 7 and 14. So common factors between 12 and 14 are 1 and 2. Do you see that? So easy, right? Good. So now we are also to find factors, common factors between 15 and 10. Do you remember how we did the previous one? Very good. So now let's continue the same method. We have 15 and we have 10. So now let's list out the factors of 15 first, and then we come back to 10. For 15, starting from 1, we have 1, right? Very good. We have 3, we have 5, and we have 15 itself, right? So easy. How about for number 10? We have what? 1, 2, 5, and 10. So easy, right? So now we have to just list out the common factors of 15 and 10. So now you will notice that we have 10, we have 1 here, we have 1 here. So we write 1 first. What other number? We have 3 here, we don't have 3 here, right? So we have 5 here, we have 5 here. So our next common factor is what? 5. Any other common factors? No. Very good. So our common factors between 15 and 10 is what? 1 and 5. Can you see that? Very good. And now here is the main event. Highest common factor. Highest common factor. We know that factors are numbers that will divide a particular number, right? Very good. Then common factors are factors that you will see in a particular number, and you will also see them in another number at the same time, right? Very good. While our highest common factor of 2 or more numbers is the largest number that will divide exactly into all the numbers. Out of the common factors, the highest one among them is the one we are going to choose as our highest common factor. Do you understand that? Very good. So now let's start with an example. So now, highest common factor of 12 and 18. We list out the factors of 12 and 18. Starting from 1, we have what? 1, 2, right? 3, very good. 4, 6, and 12, right? So easy. It is easy now for us to figure out our factors, right? Very good. How about 18? We have 1, right? 2, 3, very good. 6, interesting, right? 9 and 18, right? So easy to do. So now, let's list the factors. Let's list the common factors out. You notice that we have 1 here, we have 1 here, right? We have 2 here, we have 2 here, right? We have 3 here, we have 3 here, right? Good. What other number? We have 6 here and we have 6 here too. Do you have another number that is in 12 and 18 at the same time? No. Very good. So as such, our highest common factor is the highest number among these numbers. And what is the highest? 6. Very good. So our HCF for 12 and 18 is what? 6. You can see it is very easy to get. Very good. And I'll be showing you another way with which you can get your HCF without listing out the factors. Sometimes you can be given numbers that are high, such as 200 and 1000, you find the common factor, the highest common factor between them. Sometimes it can be three numbers at the same time, right? So we cannot be listing out the factors of 200 first before we start listing out that of 1000, and then you list out that of 300. You are going to exhaust all your pages. So I'll be showing you another method which you can use to find your HCF without stress. Here I'll be showing you the other method to find your HCF of 12 and 18 without listing out the factors. So you draw out your vertical and horizontal line just the way I am doing. So when you draw out your vertical and horizontal line the way I have done, right, you input your numbers 12 and 18. So we start with the smallest number that is going to divide 12 and 18 at the same time. You know, we are dealing with common factor. What is in 12 and is also in what? 18. So you divide by a number that will divide 12 and 18 at the same time. When we look at, we start from 2, right? We start from 2. So when you look at 2 will divide 12 and it also divide 18, right? Good. So we start with 2. So we say 12 divided by 2 gives us 6. You put your answer beneath the value we are dividing. Do you get that? Good. 18 divided by 2 gives us 9. Very good. So between 6 and 9, which number can we use to divide them? Can we use 2? No. Why? Because 6 will divide 2, right? But 6 will divide 2 without remainder. But 9 will divide 2 with remainder. So we can't use 2 here. Do you get that? Very good. So we look at the next number, which is 3. So 6 can divide 3 without remainder, and 9 will divide 3 also without what? Remainder, right? So we can go with what? 3. The numbers you are using to divide will be on this right hand side. Do you understand? Very good. So 6 divided by 3 gives us what? 2. You put your 2 beneath the number you are dividing, which is 6. 9 divided by 3 gives us what? 3. Very good. So now between 2 and 3, which number can we use to divide them that will not give us any remainder? None. So what we do now, since we already got into the stage whereby we cannot divide the two last number with a common number, with a common factor, so we stop our division here. Do you get that? And as such, our HCF for 12 and 18 is 2 and 3. We multiply them. Unlike the previous method, we just put a comma. But in this case, we multiply them. So 2 multiplied by 3 gives us what? 6. Can you see it is easy also? Very good. Now compare our answer here to the previous calculation. Can you see now they are the same answer? So either you choose this method or this other method, you are going to get your answer. But it is easier to use this method here, the division method, in cases where you have larger numbers. Do you understand? Very good. So now I want to take it to a higher level. So we'll be finding the HCF of 106, 96, and 224. Don't get scared by the high numbers. Do you get? Just follow the procedure and you'll be able to get your answer. So now let's use our division method here. We have 106, we have 96, we have 224, right? So you put down your vertical line and horizontal line just the way I am doing, right? Very good. So now we start from that smallest number that will divide each of this number without remainder, right? Very good. So starting from 2, can 2 divide each of this number without remainder? Yes, very good. So we start with 2. So now to divide this, let's divide this way. 106 divided by 2. We have how many 2 will you see in 10? 5, right? We have 6 beside 10. How many 2 will you see in 6? 3, right? So 106 divided by 2 gives us what? 53. Do you get that? Good. To the next number, 96 divided by 2. How many 2 will you see in 9? 4. And it will remain 1, right? So attach the 1 to this 6 and make it 16. Are you following? Good. How many 2 will you see in 16? 8. Very good. As such, 96 divided by 2 gives us what? 48. You can see it is easy to do. Very good. And to the next one, 224 divided by 2. We pick the first 2, right? So how many 2 will you see in 2? 1. How many of these 2 will you see in 2? 1. How many 2 will you see in 4? 2. So 224 divided by 2 gives us what? 112, right? Very good. So now between 53, 48, and 112, when you look at them carefully, which number we divide through without remainder at the same time? Is there any number that will divide 53, at the same time divide 48, and at the same time divide 112? Is there any? No. So we only have 2 in our division. So we write HCF of 106, 96, and 224 is just what? 2. Do you understand? Very good. So now let's try another set of numbers using that division method. So we have 189, 279, and 108. You draw your vertical and horizontal line just the way I've done, right? Very good. So starting from the least number to divide through without remainder. So can 2 divide 189, 279, and 108? Can 2 divide them? No. So since 2 cannot divide these 3 numbers at the same time without remainder, we look at the next number, which is 3. So looking at this, can 3 divide them? Yes. So we have 3 in our division space. So 189 divided by 3. How many 3 will you see in 18? 6, right? Good. How many 3 will you see in 9? 3. So 189 divided by 3 gives us 63, right? Very good. To the next one, 279 divided by 3. How many 3 will you see in 27? 9. Very good. How many 3 will you see in 9? 3. Right? Good. So 279 divided by 3 gives us what? 93. And to the last number, How many 3 will you see in 10? 3. And we have 1 as our remainder, right? Good. Attach the 1 to the 8 to give us 18. So we say, how many 3 will you see in 18? 6. Very good. Do you get that? So now let's look at the 3 numbers. Which number will divide 63, 93, and 36 at the same time without remainder? Good. 3 will divide them once again, right? So we go again. We have our 3 on our division space. So we divide one by one. 63 divided by 3. That is 21, right? Very good. 93 divided by 3 gives us what? 31, right? Good. How about 36? 36 divided by 3 gives us what? 12. So easy, right? Good. So now looking at 21, 31, and 12. 21, 31, and 12. Do we have a number that will divide these 3 numbers without remainder at the same time? Do we? No. Very good. So we are ending our division here, right? Very good. So as such, we write out our HCF to be what? 3 here. These 2 numbers. 3 multiplied by what? 3. And that gives us what? 9. Do you see that? It is very, very easy. As long as you follow the steps, you get the right answer. Do you understand? Very good. And now to the last example we have here. Find the HCF of 126, 234, and 90. So as we've done to the previous example, we draw our vertical and horizontal lines just the way I've done, and you put your number, and so we start to divide by the least number that will divide each of them all through without remainder. You agree with me that 2 will divide each of them without remainder, right? And it is the least number that we can use. So starting from what? 2. We put our 2 by the left hand side, right? Very good. So 126 divided by 2 will give us what? So our little division we have 12. How many 2 is in 12? 6, right? Very good. How many 2 is in 6? 3. And as such, 126 divided by 2 gives us what? 63, right? Very good. To the next number, 234 divided by 2. How many 2 will you see in 2? 1, right? How many 2 will you see in 3? You see 1, and we are going to have a 1 as remainder, right? Attach the 1 to your 4 to make it what? 14, right? Very good. So how many 2 is in 14? 7. Do you see that? So 234 divided by 2 will give us what? 117. So easy, right? Very good. So the next one is 90 divided by 2. How many 2 will you see in 9? We are going to have 4 2's in 9, right? And 1 as our remainder. Attach the 1 to your 0 to make it 10. Are you following? Good. So how many 2 will you see in 10? 5. As such, 90 divided by 2 will give us what? 45. Very good, right? Now, 63, 117, and 48. Can 2 divide them without remainder? No. So that means we can't make use of 2 again, right? Very good. So we go for the next number, 3. Can 3 divide them without remainder? Very good. So So 3 we divide each of them without remainder. So we go by 3. 63 divided by 3 will give us what? How many 3 we use in 6? 2, right? How many 3 we use in 3? 1. So that means 63 divided by 3 will give us what? 21. Are you following? Very good. So to the next one, 117 divided by 3. How many 3 we use in 11? You see 3. And you have 2 as a remainder, right? Very good. Attach your 2 to the 7 to make it what? 27. So how many 3 will you see in 27? 9. You can see it is very easy, right? Very good. So now, 117 divided by 3 gives us what? 37, right? Very good. So 45 divided by 3 will give us what? How many 3 will you see in 4? 1, remainder 1, right? Attach your 1 to the 5 to make it 15. How many 3 will you see in 15? 5, right? Very good. So that means 45 divided by 3 will give us what? 15, right? Very good. So you have 21, 39, and 15. Can 3 divide the 3 of them at the same time without remainder? Can it? Good. 3 will divide them without remainder. Very good. So we go again with 3. You can see it is very easy. Just follow the step and you're getting your right answer, right? Very good. So how many 3 will you see in 21? 7. Right? Good. How many 3 will you see in 39? 13. Interesting, right? Good. How many 3 will you see in 15? 5. You can see it is very easy. Good. So now we have 7, we have 13, and 5. Can we have 3 dividing these 3 numbers without remainder? Can 3 divide 7? No. Can 3 divide 13? No. Can 3 divide 5? No. Good. Do we have another number that can divide the 3 of them without remainder? Do we? No. Very good. So as such, our division is ending here, right? Very good. So our HCF will be, we pack our numbers that we used to divide. We pack them together. So we'll be having what? 2 multiplied by 3 multiplied by 3. Very good. And what does that give us? 2 multiplied by 3 gives us what? 6. And 6 multiplied by 3 will give us what? 18. Very good. Do you see that? Finding highest common factors of numbers, no matter how big, is easy to get. Just follow the process and you get your answer. Do you get that? Very good. And so guys, we've come to the end of today's class about factors and highest common factors. Remember, factors are numbers that would divide a particular number without remainder. And common factors are numbers that you see in a particular number and another number at the same time. While the highest common factor, which is the HCF, is the highest of your common factor, right? Very good. So I congratulate you for finishing this class with me today. And as such, thank you for listening. Kindly click the subscribe button and share. See you later.